Dear students, today I am going to teach reciprocating compressors, which comes under module 5. So first and foremost we should know what exactly the compressor is all about, and what is the meaning of reciprocation, and how does this the reciprocating compressors work. So first we will see one by one. So in the introduction part, so this is actually the diagram of reciprocating compressors. So if you look at it, so you will find piston and piston rod and crankshaft and crosshead pin and connecting rod. So actually, so this you are familiar with internal combustion engine, right? The same structure, the same components will be seen in reciprocating compressors. See, in IC engines, you will see piston, cylinder, connecting rod, crankshaft, and cylinder. So all these components you will see. The same exact arrangement will be seen in reciprocating compressors also. So the dictionary meaning of reciprocation is to and fro motion. So there is another compressors like rotary compressors which rotates in a rotary motion. That is, in a circular motion it rotates. That's why it is called as rotary compressors. Whereas in the case of reciprocating compressors, this compressor will move to and fro motion. So that is why it is called as reciprocating compressors, like backward and forward direction. That is why it is called as reciprocating compressors. So let us see that the introduction part of this reciprocating compressors. So the first one is the principle. First we will see the principle of the reciprocating compressors. A compressor is a mechanical device that increases the pressure of a gas by reducing its volume. The fluid here is generally air, since liquids are theoretically incompressible. See, in this compressor we take air as a substance. So that is why it is called as air compressors. Why we need to take air as a compressor? Because see, if you take any fluid like fluid particles, it is theoretically impossible to compress. So that is why it is called as incompressible fluids. Whereas in the case of air, so this air can be compressed. So this air is taken as a substance, and due to this reciprocating motion, so that will be compressed. So that is what the principle is all about. It increases the pressure. The main principle of air compressor is to increase the pressure of the air. So how do we increase the pressure of the air? By reducing its volume. See, there are many examples that I can quote under this. So like so we can by decreasing the volume. So by decreasing the volume, if you take a cycle pump, so there will be a cylindrical shape and there is a handle in it. So if you lift the handle of the pump, and so if you push it downward direction, so what is happening? We are decreasing the volume of the pump. So what happens? By decreasing the volume of the pump, the pressure of the air will increase. So the same phenomena will applicable here also. The main principle is to increase the pressure of the air by reducing its volume. Now let us see the classification. So the classification of air compressors or reciprocating compressors. So the compressor, first of all, the compressor will be classified into two types. So one is reciprocating compressors, and next one is rotary compressors. Again, reciprocating compressors are classified into two types. One is a single stage, another one is a multi-stage. So this is how the compressors will be classified. So first, now in our syllabus that we are going to study this reciprocating compressors only. So let's see that reciprocating compressor, volume of a gas drawn into the cylinder, it is trapped and compressed by piston and then discharged into the discharge line. The cylinder valves control the flow of a gas through the cylinder. These act as check valves. Reciprocating compressors can be single acting or double acting. So what does this the theory say is that in reciprocating compressor there will be two different valves. One is inlet valve, next one is exhaust valve. So during that suction stroke, the air will be sucked inside the cylinder, and then the compression stroke, the air is compressed. By that, the pressure of the air will be increased. So that is what the working principle of these reciprocating compressors. Again, so as we have seen in the classification, So this is a single acting reciprocating compressors, single acting compressors and double acting. So only one cylinder or one in one particular motion. So the air is compressed, that is called single acting. In one particular motion, both the sides are compressed, that is called double acting. So we here we see what is single acting and double acting. Single acting is compression is done in single stage or by single cylinder, and it is used for generation of low pressure. Obviously, the for the low pressure air is obtained with the help of the single stage reciprocating compressors. When it comes to double stage compressor, it's a highly pressurized air, and it is used nowadays in heavy duty mechanical devices. These double stage reciprocating compressors are used. So it will be done in double stage, two stages. This air will be compressed. Now this is the constructional details of reciprocating compressors. So there are different parts you can see in these reciprocating compressors. So suction valve, suction chamber, piston and piston rod, cylinder, discharge valve and discharge chamber. So if you look into this diagram in detail, so on top of it there will be two different valves. One is a suction valve or chamber or discharge chamber, and so if you come inside, so there will be a compression chamber. So you can see that compression chamber where that air will be compressed, and with the help of piston underneath there is a device called piston, and the piston is connected to rod, that is a what you call connecting rod, and then the connecting rod is connected to crankshaft, and this crankshaft will be connected to crank, and crank will be connected to crankshaft. So this is the constructional details of this reciprocating compressors. Now if you see the valves, so there will be two different valves, a suction valve and delivery valve. So this is automatic type obviously, and during the suction stroke this inlet valve gets opened and air will be sucked inside. So during that time, so delivery valve will be closed, and during compression stroke, so both inlet and exhaust valves will be in closed condition. So now, so this is all about the valves. See, the valves are of automatic type. They open due to the effect of differential pressure between cylinder and the suction or discharge chambers, and close due to the force of spring acting on the plates plus the differential pressure across the walls. See, there will be a spring type of structure will be fixed on top of the inlet valves and exhaust valves. So during that pressure difference between the atmosphere and inside the cylinder, so because of the temperature difference, that inlet valve gets opened, and air from the atmosphere will be sucked inside the cylinder, and then so both valves will be closed during compression stroke, and then air will be compressed with the help of the piston, and so that opening and closing, so there will be a springs fixed in both the inlet and exhaust valves. That movement will be given by the springs, and springs are used for smooth functioning of opening and closing of the inlet and exhaust valves, right? And if you look at this, the last one, the stages of refrigerant in a reciprocating compression. See, these are the different stages. If you look into this very clearly, so 1 to 2, 2 to 3, 3 to 4, and 4 to 1. So there are 4 different stages. So this is drawn between pressure and volume diagram. So this graph between pressure and volume, and 1 to 2 process. This, if you look at this 4 to 1 process, that is the suction intake volume. So during this 4 to 1 process, that air will be sucked inside the cylinder, and during 1 to 2 process, air will be compressed with the help of the piston. So that is what the adiabatic compression during that stroke. So entropy remains constant, and temperature increases from T1 to T2, and pressure increases from P1 to P2. And discharge 2 to 3 process is a discharge through that exhaust discharge valve, so the air will be discharged, and then so 3 to 4 process is expansion stroke. So it comes back to the normal pressure, and then suction starts immediately. So there will be a clearance volume. So the clearance volume is provided in the top of the piston, when the piston is at the top dead center. Why the clearance volume is given in any cylinder? To avoid the breakage of the inlet and exhaust valves. and so that smooth functioning of that piston movement will be there, and the piston displacement will be from 1 to 3, the total displacement of the piston, and the total cylinder volume. So how do we define the total cylinder volume? Is clearance volume plus piston volume, or we can, it is also called as stroke volume. So total cylinder volume is equal to stroke volume plus clearance volume. So that is how that that it is that formula is given as that total volume is equal to clearance volume plus stroke volume. So this is all about the basic concepts of the reciprocating compressors. Thank you.